students, I hope your preparation is going good. If not, don't worry. Sri Gurukula is here to help you. And I am Anmol Yadav. I will be your physics and mathematics mentor. I am an NIT-JEE graduate. So bring out your books. Let's make your preparation stress-free. So next question is the direction of the electric field vector at a point on an equatorial line of a dipole is. These are our options in the same direction of the dipole moment, opposite direction to the dipole moment, towards negative charge or towards positive charge. So let's try to understand what is a dipole moment. Dipole moment is when two equal charge are placed at some distance d, then q into d will be our dipole moment. So let's take two different charges, two opposite charges, minus q charge and a plus q charge. And this equatorial line is the line passing through their midpoint and perpendicular to the distance between them. Correct? So this is our equatorial point. So our electric field at any point on this equatorial line will be in which direction? That's what they are asking. So let's take a random point here and let's make a triangle. Let's make a triangle. So electric field due to positive q charge is away from the charge, right? So electric field from positive q charge will be in this direction, and for negative charge will be in this direction. So at this point, due to positive q charge, the electric field will be something like this, E, and for a negative charge will be in this direction, same amount E, correct? Because the quantity of charge is same and the distance is same. If it's equatorial line, then this will be an isosceles triangle. If it is an isosceles triangle, these two angles will be equal and these two angles will be equal. So let's suppose this angle is theta, so this angle will also be theta, correct? Now let's divide this electric field into two components, a vertical component and a horizontal component. Let's take a horizontal line. So this is our horizontal line. So this line is parallel to this line, the distance between minus q and plus q. So if this angle is theta, this angle will also be theta due to corresponding angles. See, these are parallel lines and these are corresponding angles. If this angle is theta, then this angle will also be theta. See, this is making a z. So these are alternate angles. Now let's divide E into the components. E cos theta, so this will be E cos theta, and this component will be E sin theta. Similarly, E cos theta again, E cos theta again, and in this direction we will get E sin theta, E sin theta. See, E sin theta, two same quantities, two same amount in opposite direction, so they will cancel out each other, and these two are adding to each other. So net electric field be 2E cos theta, and it is in this direction, correct? So it is in this direction, and dipole moment is in the direction, the direction of dipole moment is from negative charge to the positive charge. So direction of dipole moment is something like this. So this is the direction of dipole moment, and this is the direction of electric field at any point on the equatorial line. So they are opposite in direction. This is going in negative direction, this is going in positive direction. So our correct option will be option B. I will be back soon. Till then, keep practicing. This is Anmol Yadav from Sri Gurukula signing off.